it on? Hello, everybody. Hey, welcome to Comics Curing Cancer. Introducing your host, Matthew Murtha. Woo!
Are you guys ready to talk science tonight? Thank you for joining me. Once again, this is Comics Curing Cancer, a science talk show. For you guys that don't know, we're recording this live for Facebook, radio, and podcasts. So for our listeners out there, this is recorded in front of a live studio audience of, I'd say, probably 3,000 people. And for my live audience, I want to assure you this is going out to tens of millions of people worldwide. We have a great show tonight where you have Dr. Fergus Simpson here to explain the mysteries of dark matter and the search for extraterrestrial life. So without further ado, let me welcome our co-host for the evening, Miss Hannah Becker. Welcome, Hannah.
Oh, hey, everybody.
How have you been doing?
I've been good. I like this selfie mode.
This is our live stream.
Live stream going on here.
Just kidding. It's just so that I can see myself.
Yeah. I'm just going to be looking at myself the whole time.
I assure you it's cute online.
Yeah.
So, our comedian, Miss Hannah Becker, what do you have going on this week?
Oh, yeah, this week I'll be hosting Stand Up Comedy Live on Wednesday. So just come out. That's at Craft Bar. What time does that start? At 9?
10 o'clock.
10 o'clock? Well, before there's a...
Host with the most.
Yeah, God. No, because before there's a radio show that starts, I think, at 9. But yeah, the show starts at 10. I'll be hosting. We have a good lineup of comedians, so come check it out. Yeah.
Please, everybody, just calm down.
God.
Get back in your seats. It's going to be a long show, all right? Get comfortable. So how about we get it started with some comedy news and
let's
science?
do it.
This is our theme song.
Do we have a jingle for this?
All right, so getting started. According to a recent article in The Telegraph about research published in the esteemed St. Petersburg Polytechnical University Journal, Physics and Mathematics, they published that 2 dolphins have been recorded for the first time having conversations just as people do.
Or maybe we have conversations like dolphins.
Maybe you do, Hannah. However, though, we've known for a while that dolphins possess advanced systems of communication, right? In 2007, a research team from Australia decoded some of these messages, and they translated certain sounds as meaning, "I'm here, where is everyone? Hurry up, and there's food over there."
Yeah, it just sounds like me when I get to a party before all my friends, and I'm texting them, freaking out, "I'm here, where's everyone? Hurry up, there's food here." Yeah, dolphins are just like us.
Again, maybe just like you. I'm not saying that you're a large aquatic animal, but maybe.
Okay.
So, anyway, scientists have also observed that dolphins tend to communicate more when trying to solve a difficult task, such as opening a jar underwater. Yeah?
Are they the dolphins grandmas? Right? Like, "Bubala, can you open this jar for me? My arthritis is acting up." "All right, Grandma, all right." Can't get this open. "Oh, all right, let me try. Oh, it just popped right off." "Oh, well, I loosened it for you, Grandma."
Your dolphin impersonation is just uncanny.
Yeah. That's how my grandma dolphin talks.
I don't know. If I had to guess, I would say they were probably saying, "Damn, I wish I had some thumbs."
Probably.
It's a jar.
Opposable thumbs.
The first step in proper evolution. Anyway, researchers in Sweden, they were studying the parasympathetic nervous system, right? The nerves that govern the flight response. And these researchers made the astonishing discovery of the nerves that actually cause erect nipples.
It's definitely the
True story.
work of super serious scientists.
Well, I think that you can tell that they're scientists because they think they discovered erect nipples.
Yeah, when we contacted them for a comment, their response was, quote, "We were amazed to discover signs of arousal during our neuroscience studies. We had heard of these, but thought they were a myth. We believe this work will be seminal and even perhaps lead to evidence for abstract concepts such as, quote, fun and, quote, sex." End quote.
I'm still waiting to see that pan out in research. But coincidentally, an article in Vox was discussing the link between Neanderthals and humans, and there's evidence that they co-bred. And so this article is discussing the merit of whether or not humans actually loved Neanderthals. Yeah?
So romantic.
I can just imagine the candlelight dinner over stuffed mammoth? I'm not sure what they ate. However, we know that humans and Neanderthals interbred because actually about 5% of the human genome consists of Neanderthal DNA. But again, the question though is why on earth would a human ever have sex with a Neanderthal?
I mean, the same reason why women have sex with you.
Because of my rapist wit?
No, well, the article mentioned, I thought this was really interesting, that most mammals have spines on their penis. Yeah? So I did a lot of Googling about this, of course. I was very curious. And so most mammals, it's hard to have sex with a human because we're not designed for spiky penis sex. Yeah? So Neanderthals, just like humans, did not have the gene for spiky penises. So they could have sex with each other.
Right. And then that suggests that the women that sleep with me do so only because I lack spikes on my penis.
Yeah, I mean, why else would they?
Fair. However, I think that says less about me than it does about the women, because they're like, no spikes? Well, all right. Let's give this a shot. Let's do it.
It's the only thing you got going for you, Matt.
Apparently. Moving on. And this is a surprising study. So monkeys in a lab at Stanford University have been trained to type Shakespeare and passages from the New York Times using only their brainwaves.
50 Shades of Grey was rejected as a sample text by the ethics board to prevent cruelty to animals.
I think that was a smart choice. So the researchers were surprised when one of the test subjects actually accidentally earned a degree in English literature. They were less surprised when they found out that the degree was from the University of Wisconsin. It's not an Ivy League school, folks.
Not a good school. But now able to communicate their thoughts clearly, the monkeys quickly protested their working conditions as inhumane. Researchers defended the conditions on the basis that they were typical conditions for graduate students.
They should be lucky they have a job. That's what most principal investigators say.
Yeah. Oh, so I saw this article, speaking of grad students, about a grad student who did an experiment proving that she could make yogurt with her vagina. Yeah, this is crazy. It turns out that the main bacteria found in a healthy vagina is the same bacteria used to make yogurt. So this grad student, this young woman, made a bowl of vagina yogurt and ate it, like twice. So what do you think about that, Matt? What do you think?
I have some problems here. First off, this is disgusting. Yeah, hands down, it's disgusting. First of all, yogurt, it's nasty on its own, but made by a graduate student. Why would you ever eat that? That's horrible. But worstly is that if you read this, you find out what the actual experimental conditions were, and it is a travesty. It just pisses me right off. So this girl, right, she comes up with the hypothesis that if the vaginal flora contains lactobacterias, which apparently it does, and that the main bacteria component of the yogurt starter culture is lactobacterias, that, of course, vaginal juice will make yogurt, yeah? So she gets 3 bowls, puts milk in each bowl, and she has a positive control. She inoculates that bowl with the standard yogurt cultural starter pack. In the center, she has her experimental condition, which she applies, I can only imagine, a healthy serving of her own love. And in the 3rd bowl, it's the control, right? She doesn't add anything to that. And so she lets this bake for a certain time, and then lo and behold, in 2 of the bowls, she gets some yogurt-looking material. Now, ladies and gentlemen, there were no replicates. This is shitty science, yeah? Calm down. Obviously, you're all as upset as I am. But there was no replicates, no alternative hypotheses tested. It's shitty science. It's a shitty experiment. And I get disgusted thinking about it. Let's move on.
Yeah. So I think that's
all the news
That's all
and
we have.
science.
That's all of our comedy news and science. Science, news, and comedy. However you want to say it. That's it.
Comedy, news, and science, I think. Yeah.
Comedy, news, and science. Yay!
Thank you. So at this point in time, I usually like to begin with a monologue, kind of outline what we're going to be talking about tonight. And so for tonight's episode, I actually created this whole explanation on how to think about other dimensions, yeah? Because tonight's guest will be discussing dark matter and things that are not observable and things that perhaps could lie outside of the observable universe as we know it. And we got to talking, and I said, he mentioned that, like, well, of course, this is true in this universe, but perhaps not all universes. And I was like, what do you mean, other universes? It's one universe.
Dun, dun, dun.
And he says, well, no, there's actually a multiverse that contains multiple universes within. And that got me thinking. And so I created this elaborate scheme to show that if you could bend the axes of the three-dimensional space, you would actually create a surface, right? So you have the x, the z-axis, the x, and the y, as we all know. And I made this contraption where it bends in. You could actually see that what we consider physical space could actually circumscribe a volume within another set of dimensions. And I proposed that we could have dimensions being time, right? Because we know that time is related to space. And also, if you can imagine, again, the three axes, they spread from the point of origin, where there's no space, and they expand out infinitely, which is kind of how we think about the Big Bang, yeah? So it made sense to me. And then I proposed another axis, gravity. And I said, well, gravity and time are connected. And of course, gravity and space, mass, is connected, so that made a lot of sense. And I said the third axis now was going to be energy. Because of course, energy and gravity are connected. Here in Spain, we say, Tío Alberto. He taught us that, yeah? Uncle Al. Mr. E equals MC squared, himself, Albert Einstein. So I explained this to all my friends over the weekend, and every time they said, Matt, that makes no sense whatsoever. So I'm gonna leave that, and we'll
Glad
just pretend.
you just explained it then.
Yeah, I know. Well, we got some time to fill. But no. So tonight we're gonna let our own professional astrophysicist explain these concepts and more. So I'd like to welcome to the stage PhD from Cambridge University, postdoc at University Edinburgh, postdoc now in University Barcelona, Mr. Dr. Fergus Simpson himself. Woo!
Is that working?
Closer.
Is that better?
Sounds beautiful.
All right.
See, you can see yourself now too.
Oh, yeah. It actually works.
The magic of technology. All right, so I'd like to start with just some personal questions so we get an idea of who you are as a person, and then you can tell us a bit about your research. So just starting off, where are you from?
I'm from Scotland, Edinburgh.
Very nice.
Do you want more details?
Very factual.
That's my job.
Yeah. How did you get interested in science?
That's a tricky one. I guess I've just always been interested in what we're doing here and how do we come to exist here. So I've always been interested in the sciences and ended up doing a degree in physics.
What were you like as a child? I mean, were you like elbows deep in textbooks even then, or?
No, I guess I was lapping up like the documentaries, like the David Attenborough stuff. So it wasn't necessarily like the physical side, like astrophysics. It was also like marine biology, other things like that.
When did you start specializing in physics?
I guess when I started at university. But even then, I had no idea that I would specialize in astronomy until my last year.
Oh, yeah? So you took generalized courses, and then you sat in front of a telescope, and you're like, no, this is the shit. This is where it's at.
I know, I hated the practical stuff. I was more on the theoretical side. Yeah, I got really bored of being stuck inside doing experiments. So I was pretty sure I was going to quit. But in the last year, you got to choose to do what you wanted. Basically, you should go to proper tasted research where you ask your own questions, and you don't have to just follow the textbooks. So that's kind of what drew me in, I suppose.
Academic freedom.
Yeah, yeah. And so I did a project on whether you could have planets like the Earth around other stars, even if there was a planet like Jupiter in where Mercury is close in, and see if that was possible. So yeah, I really enjoyed that.
What did you find out?
The answer is pretty much yeah, you could.
Yeah?
Yeah.
Very nice.
Yeah. It's so it was very encouraging because we know of many systems like that where there are very large planets very close into their star. So it's still quite feasible that you could have a planet like the Earth in that situation.
So when you're at a bar, do you just tell people that you invented that? Yeah, when I was a senior in college, I discovered planets.
I think they usually enjoy the Big Bang Theory connection more. But
yeah. Oh, okay. We'll talk about that in a moment.
I'm sure.
Let's see. Next. See, these are just questions we ask everybody. So how do you feel about being a lady scientist? I'm sorry. I think that was from last week. Last week question. So what do you find most frustrating about science?
Most frustrating about science? I guess it's a fairly slow progress. People talk about the rapid advancement of technology, but it still feels like it takes a long time to get to that next stage. And there's been big delays. For example, the James Webb Space Telescope has been delayed many years. So yeah, but it's.
So day to day, how do you describe your feelings as you do your research? Are you generally frustrated and impatient, or do you like your life, or most researchers I know are like barely almost suicidal.
Right, but is that lab work though? Maybe it's slightly more intense in the lab. Is that right? Or working with living beings?
It certainly feels way more intense. Maybe we just need to become theoretical.
Well, it's better because you can actually work on the beach, So if you got some piece of paper and some equations, then it's a bit more relaxed.
So join us next week as I describe my journey in switching fields. So tell me about the Big Bang Theory. How do you feel being compared to these assholes?
No, I found it quite entertaining, to be honest. I was always envious at uni when all these medical dramas were on, and my friends who are medical students were really enjoying that. And there was no equivalent in the physics field. Now there is. So
So
shame
I don't
that
know.
It's such a terrible show. Sorry.
I thought. So I remember watching a Grey's Anatomy with an ex-girlfriend, and just being astounded about the amount of sex that doctors seem to have in closets. So I don't think that Big Bang Theory is an equal.
Right, it may not be equal
comparison,
but it's certainly heightened. Look, so the take-up of physics has shot up in the last decade, and a lot of people are attributing that to the success of that TV show. So if it's doing that, then it's definitely worthwhile.
And do you think it really captures the life of a physicist?
In a roundabout way, yeah.
Do you have a whiteboard at home with equations and?
I have a corkboard, yeah.
Yeah?
Yeah.
What is the nerdiest thing that you like to do or follow?
Good question.
So many things.
Yeah.
Can't pick just one.
Don't know. I guess computer games is the classic, right?
All right.
Yeah.
What do you play?
At the moment, Rocket League is quite good. You should have tried that.
I don't know. I'm not a nerd.
Shut up, nerd. All right, so how about you tell us a little bit about your research?
Sure. So it probably falls into two categories, cosmology and astrobiology. But they're both linked in the sense that they're trying to answer where we came from, answer really fundamental questions. So I guess my PhD was predominantly in cosmology, looking into this stuff that we call dark energy and just trying to find out what the universe is made of. I think what drew me in really was the big challenge and the big uncertainty about the fact that only 5% of the universe is stuff that you're familiar with on the periodic table. Everything you learn about in chemistry, biology, everything you see in the sky. For every star you see in the sky, there's 5 times as much stuff in the form of what we call dark matter. And so all that kind of uncertainty was a challenge to...
Just as a point of clarification, so what we think of as dark matter, you're not talking about like nothing, right? The emptiness of space. That there's something there.
Exactly. So the name maybe isn't ideal, because if I say dark matter, you might just think of some black object that's not emitting much light. But what you should really imagine is something that's kind of transparent and untouchable. So more like a ghost matter maybe is a better description. And the only way that we really sense it is through gravity.
Okay. See, that model I was going to build would have been helpful right now.
Sorry.
I'm sorry. So, what now? Like the classical evidence for dark matter is the fact that the universe is still expanding. We expected after the Big Bang things to slow down and kind of contract back, right?
So that's the big evidence for dark energy. For dark matter, it really started a long time ago, back in about 1933. We saw galaxies moving really fast around each other, and they were moving so fast that you'd expect them to just fly apart. So what was holding them together in these orbits, there must have been a lot of mass there to have that gravitational force to keep them in the same place. And you're right, it did control the expansion of the universe for the first half of its life. And then for the second half of the universe's life, it's done something even weirder, which is to accelerate, and that's what we give the name to this other thing, dark energy.
Why is that weird?
Because it's the only material we know of, or phenomenon we know of, that is gravitationally repulsive. It's pushing stuff away. Mm-hmm. So everything else acts just like when you throw an apple up in the air and you get the gravitational attraction.
Mm-hmm. Okay, no, I guess I'm sure I've learned this at some point, but I still don't understand. Why do we expect the universe to stop expanding? Why is that the expectation?
In the same way that when you throw an apple up in the air, the gravitational attraction between everything that is in the universe tends to slow down the expansion generically.
Okay.
That was what was happening for about 6 or 7 billion years. It was slowing down and changing and getting cooler and so on.
Mm-hmm. How do we know that?
So cosmology, the way cosmology works observationally, you should really think of in a bit like archaeology. So the deeper you dig into the depths of space, you're looking back at different epochs, different times at the age of the universe, and we see its properties changing. So we see not just galaxies getting redder, but they're changing in their properties, and we can actually look almost all the way back to just 300,000 years after the Big Bang. You see the surface of a fireball, basically. So we can basically see the surface of the ripples in a fireball that was the Big Bang, which is pretty intense.
I feel like that should have been a bigger discovery.
Yeah.
Because a lot of people are treating the Big Bang as if it's still theoretical. I swear, family members that, will testify that the world was created 7,000 years ago by big white man in the sky.
Thanks, Midwestern America.
Yeah.
Yeah.
So you're saying that they can actually see the remnants of the fireball itself?
Absolutely. In fact, it's probably the single most important observation we have in cosmology, and it tells us an awful lot about the universe, because these tiny little ripples at the end of the fireball phase. So I should probably explain, so why the universe has gone from this fireball phase to where it is now. So if you went into deep space right now, you'd find it's around 2.7 degrees above absolute zero. You'd be pretty cold out there, right? So why is it so cold? Well, it's just like when you spray an aerosol can. There's a lot, as the gas expands, it cools, pressure drops, and the temperature drops with it. And so the universe has transitioned from a very hot state to this cool state that we're in now. So we see sufficiently early times, 14 billion years ago, we had this fireball state that we see the end of. And we see in the ripples that there was most material during a fireball is being thrown around by the fact there's a hell of a lot of radiation going on, and it's just a mess. But we see a signature in the ripples that tells us there was a lot of material that just didn't care there was a fireball going on, and it was just minding its own business, falling into gravitational wells. And that's exactly the way that we expected that dark matter would behave, because it doesn't see the fireball. It's dark. It's invisible. It doesn't touch the light.
So dark matter is only affected by gravity then?
Yeah, exactly. It may also experience something we call the weak force, but that's an incredibly, as its name suggests, very hard to pick up on.
Right. For those following at home, that's one of the forces that operate on a subatomic level,
Indeed,
right?
yeah. It's responsible for radioactive decay.
Ah,
yeah.
Obviously. So when you talk about looking back in time, is it all just telescopes studying very old galaxies, or do you have, far infrared spectrometers,
right.
or what's your favorite gadget? What do you have on your bat belt?
Yeah, as a guy, so to spot the galaxies, you indeed use something you would think of as a traditional telescope, just rather large, or one that's in space.
All right, now don't brag.
But to pick up on this fireball effect, the cosmic microwave background is called, not a great name, not very catchy. They need something that looks very different. Just measuring heat, basically. But that's really the most important thing that we've had is, in terms of telling us what the universe is made of and how it's been changing.
And these sensors are in satellites or here on the Earth?
They're on both, actually. So we've sent some into space, but there are also some down in Antarctica, looking at small patches of the sky. So you get the best of both worlds.
Clearly.
Yeah.
So you mentioned the cosmic microwave background, yeah?
That's right, yeah.
And so this is what led to the recent kind of quote-unquote discovery of the gravitational ripples. Are these the same ripples that you were talking about before, or?
No, so there was a slight... I've got to be very careful here that I don't say anything too confusing, but there was a slight false alarm about gravitational waves in the cosmic microwave background, but the ripples I'm talking about are simply gravitational, as in not the waves themselves, just the gravitational mass that the dark matter contributed to, and that's what we see in the ripples. And then that's won a couple of Nobel Prizes along the way.
Can you, because I'll butcher it for sure, but can you explain the importance of what gravitational waves would mean for our understanding of the universe?
Right. So,
or we can move on if everybody is bored to tears.
I just have to be very cautious by what I mean. So it can be a little bit confusing because you may have heard of gravitational waves being in the news recently from when two black holes smashed together. But it's also potentially something that was generated during the Big Bang. And one of the main ideas we have about the Big Bang, called inflation, does predict that we would find them in these ripples. But it's really, really hard to find. So I'm not too optimistic that's actually going to happen.
Damn. But I guess what I was trying to get at, though, is that so the observation of these gravitational waves, I forget. So this would prove Einstein's general theory of relativity. Is that the import?
So Einstein's theory of general relativity is already very well tested. So that's a fantastic achievement. Well, what it will tell us if we found it in the microwave background is it would tell us about how the Big Bang happened. And what's really fantastic about finding it from the merging of black holes is just there's a whole new way to look at the universe and make measurements. But there was a huge amount of misreporting in the press about how it was proving Einstein's theory, because that really wasn't the key issue as such.
Yeah. So as an active researcher, what do you find misreported in the press the most?
Oh, everything. So it's very hard. Very rarely is there a correlation between what the journalists find most exciting and what we find most exciting.
But why do you think that is? Or can you explain why you think that is without sounding like an asshole? Because when I do it, I'm like, oh, well, everybody's just an idiot. They can't see the beauty and importance of my research. But
well, I guess you just had to have the background in that particular field to appreciate the significance of some of the breakthroughs that happen. And it's quite hard to convey that in a few hundred-word article. So yeah, the journalists certainly have a really tricky job getting that across. And I'm not sure I would be able to do much better, to be honest. But there's now fantastic YouTube videos doing great jobs of explaining science. So
we're going to talk about YouTube videos. Don't worry. He's got a good one.
He has a great YouTube video. Because what do you think is the most significant discovery that you've been a part of, or that you've been that's been in your time? I don't know how to word that.
Good question. So I guess I'd quickly pick up on two. One was I was part of the team called the CFHT Lens survey, and we mapped a map of the sky about how light has been distorted by gravity. And again, that was a really important another piece in the puzzle of dark matter. We were seeing how dark matter was distorting light in the sky.
How is it distorting light in the sky?
So you might not really notice it on a daily basis, but light kind of falls under gravity. And you don't notice it in the same way you don't notice a bullet falling when you shoot it out of a gun. It just doesn't have time for the distance you're seeing it travel. But of course, in astronomy, the light's been traveling for billions of years, so it can be distorted significantly. And we, in fact, see that the galaxy's shapes are change as we look back in time. And that's because of the clumps of dark matter that are pulling the light back and forth.
Dark
Is it
matter?
though? Like, how do you know that, or is it not?
All right, nerd boy, explain it.
No, because couldn't it just be
No, that was
gravity? Or no, because there's no gravity in space.
Oh yeah, no, there is. Yeah, it's the most important thing. Yeah.
Okay, never mind. I don't know.
gravity
what I'm
is
talking about.
everywhere, Hannah. Come on.
But I thought, okay, never mind. But so
So
how
when
do
you-
you know that it's not just gravity, or it's not just because it's been traveling for a long time, or like whatever,
So
that
it
bounced
matches
off
up-
an asteroid? Who knows?
Well,
Like,
partly is the signal really matches up really well with the prediction that we have in our idea of how the universe works. So if you looked at two galaxies on the sky, they appear to line up very slightly because of this distortion that gravity has imposed on it. It's hard to describe the distortion very accurately, but it's a bit like if you look towards the bottom of a swimming pool, you notice the light having these strange ripples and distortions because it's not passed through the water. It's a entirely smooth process.
so dark matter is like a swimming pool?
Yeah, no.
More complicated than that.
So dark matter form is the main form of lumpy matter in the universe. So it's responsible for a lot of the gravitational attraction that goes on between stars, galaxies, and the light that's being pulled around as well.
Okay.
Light does not have mass. Yeah? True or false?
It has no rest mass, but it has energy, so it can gravitate. So it was actually responsible for, during the early stages of the universe, it was like the main gravitating material. But you're right, it doesn't have rest mass.
He said, I'm right. Moving on. But no, I don't know. I find that interesting. So what's the distinction that you're making here between resting mass and energy? Or
Right.
we know that they're equivalent through this famous equation.
Right.
But I guess what is the impact of it? So
So, well, if you... This is going to be tricky.
just... But like again, though, this is a point I made last week. This is what I love about talking about to real researchers, because you notice he takes a pause before he says something. He thinks before he says it, and it's because he wants to get it right, and he also is thinking through the different ways and the limits of what is actually known and correct. Again, if he was a lawyer, he would just tell you, this is the way it is, even if it's completely wrong.
Yeah, so it's important to appreciate that when I said rest mass, it's the mass that a particle appears to have when it's at rest, and as you start moving close to the speed of light, you appear to gain a huge amount of inertia. So,
Is light ever at rest?
no.
So how do you know? It doesn't have rest mass.
You got me there. I'm done.
All right, so let's talk a little bit about your new work. So now you're spending your time modeling the conditions under which life could exist out in the
That's right.
in outer space. Yeah.
Alien life. Yeah.
So how do you go about modeling this? Well, can you talk us through it a little bit, and then we can ask a question.
Sure. Is this for me, really? Oh, I need a bit. So I guess for a long time I thought, like most people, that we can't really say anything about what alien life would be like, and our best guess, if we came across another technological civilization, would be that they're similar to us, like the classic Star Trek kind of species, right? But turns out that's not really the case. So it turns out it's a fairly basic result in mathematics. It is if there are groups of different size, you're more likely to be in the bigger group. So for example, if you get on a metro on your way home today, or you pick up a plane next week, I know which plane you're getting on, which country you're flying to. But I'm going to tell you, I'm going to bet with you that there's more people on that plane than other flights that day. Oh, that's very interesting.
Is that me? It's alien life.
Yeah.
They're contacting us now.
I knew they were going to contact me first.
I'm also
No, they're contacting Fergus.
Shut up,
Like,
man.
stop talking about us, man.
You said it would be a secret.
Fergus has already been in contact with aliens.
Is that really your cell phone, though?
Whose phone is that?
It's not mine.
No, mine flight mode.
Turn off your. Who? Is it yours?
This is the beauty of live entertainment, folks.
I'm gonna be
Never
really
know what's
embarrassed
next.
if it's no. Whose phone is that? Is that your
It's
phone?
not
Vanessa?
important. All right, so going on.
Okay, my point was, if you next time you get on a plane, next time you get on any form of public transport, take a note. Think about it. There's probably more people on that than there are on all other planes that day, for example. And I haven't had to know anything about the transport system you're using or what you're doing. That's just a statistical fact, that you tend to belong to larger groups. And the same applies to your blood type. You're more likely to be one of the 4 common blood types than the 4 rare blood types. It doesn't matter how you make the groups. And the same applies to countries. 98% of the world's population live in countries of over 8 million people, despite the fact that half of all countries are less than 8 million. We just don't think about them very much. They're not in the news as much because there's not so many people in them, right?
They're not important.
Yeah.
USA.
Just saying, it's a real big country.
So now when you take the next step up and think, imagine that humans had colonized planets. Imagine we colonized Mars and Venus and so on. We'd be having the same discussion and saying, well, it's more likely to be on the Earth rather than Mars and Venus because Mars and Venus have only got a few million people and we've got the 7 billion here, right? So by extension, planets are just, a colonization on a different planet is just like a different country that's a little bit further away. So if you're happy with the idea that you've got a 98% chance that you were born in one of these larger countries, you should also reckon that there's 98% chance you're born on a planet with more individuals than most other planets. And that's not an entirely new result. That was proposed back in the 90s, actually. But where I took it was one step further and said, hang on, population is actually pretty important. It correlates with a lot of things. And across the animal kingdom, for example, it's very strongly correlated with body size. So you get a hell of a lot of ants per square kilometer because they don't need much energy per ant. You can have billions of them. And indeed, they outnumber humans vastly across the Earth. Whereas larger animals like elephants, they need much more energy. There aren't so many of them. And that's just a general trend that we see. The population density scales with body size because they need more energy. So you apply that to, if you imagine there is a swathe of alien civilizations out there, and the universe is so huge, that's not a ridiculous statement. It is a ridiculous statement to assume that there's lots in our galaxy, but there may not be. But across the universe as a whole, it's pretty much an inevitability given the scope of the cosmos. So you imagine that these range of creatures that are sentient like us, that think the same way as us, wondering about what we're doing in the universe. There's a 98% chance that we have a high population, and therefore there's a very good chance that we are the physically smaller bodies as well. And you can apply this to other things like the size of the planet they're on, and you begin to build a picture that we're actually kind of freaks amongst all the aliens, right? We should not expect ourselves to be normal. We should expect ourselves to be like the Pakistan or India, not the New Zealand, not the Slovakia.
Well, hold on now. Because I always like to think of myself as exceptional.
Right. You're quite
so
entitled to do
this
that.
seems like I believe in your research quite a bit. But no, so what are you trying? Are you saying that there's planets, large planets with just one big ass animal on it, and then?
No, I'm saying that there's not. I'm suggesting it's kind of crazy to think that they've all got populations of 7 billion, right? There's going to be variation in populations. Some will be in the millions. Like species on Earth, like elephants and dolphins, they only are like 2 million of them each, roughly. So there's going to be big variation in that in the population sizes, and we should expect to be very much at the high end of that tree.
But what if we're not? Like what?
So that's a common question, but that's a bit like you're about to throw 2 dice, and I say to you, you're probably not going to throw double six. 1 in 36 chance you're not going to throw double six, and you say, what if I do? And yeah, you could be right, but the odds are stacked against that probability happening, and that's kind of my point. So you can never say anything in science with absolute certainty. We're always just trying to stack the odds in our favor. We just try and get at that point of higher confidence, 95% confidence, 99% confidence, but we're never quite certain of anything.
Well.
So even the discovery of the Higgs boson, the biggest discovery in science probably of the decade, that was only about 99.999% confidence. It's still not actually perfect, in a sense.
Yeah, I wasn't aware that we had discovered that.
Oh, the Higgs boson?
Yeah.
Yeah.
That came out of CERN?
Indeed it did, yeah.
Good job, CERN.
Woo.
Does everybody know what CERN is? No, nobody knows. Nobody. I know
knows.
one guy who knows.
I'm not even a scientist, and I know what that is.
Do you want to just, real quick?
So the Large Hadron Collider is based near Geneva, and it's a giant particle accelerator that's done a fantastic job of advancing our knowledge of particle physics. And they found that if they smashed particles together at a particular energy scale, they get a bit of a blip, and that blip corresponds to lots of Higgs bosons being produced, suggesting that it does indeed exist. And this particle is kind of weird. It's this thing that gives all other particles mass. So if this thing didn't exist, we'd all be flying around at the speed of light. So it's kind of important.
No,
It's
it's
kind of
boring is what it is. We could all be
Exactly.
flying.
That was my thought exactly.
Damn it.
I want to fly around.
Let's get rid of them.
All right, but
That's-
back to
No more
aliens.
Higgs bosons.
Back to aliens, though.
Yeah.
Yeah, back
So-
to aliens. Back to aliens.
I understand that you're not a biologist, but when you say you're modeling life, do you always imagine it being, a large multicellular organism, or because really, and let's go down at one level first and say unicellular, because there's more bacteria in my gut than there are people on the planet.
Sure, yeah.
So, like statistically, then what you would expect is like a little slime mold on a rock in a planet way the fuck out there, yeah?
Right, so sorry, I should have clarified. When I talk about aliens, I'm talking about sentient beings, but absolutely,
Good ones.
it's absolutely really important to also look for non-sentient aliens too. It might be easier to find, and there may be more of them, but it's harder to find them if they're not broadcasting radio.
But what
Ouch.
if they have like a different, like, what if aliens have a different kind of, they have alien radio, and we don't
Yeah,
know how to
that's-
detect it?
That's a very good point.
I don't know what that would look like, but
Yeah,
like,
so it's important to keep all eyes. So the funny thing is about very recently people realized that maybe shining lasers is a better way to draw attention across interstellar distances. So people are genuinely looking at stars in the distance going, is there an alien shining a laser at me? They're using actual telescopes to do that. Isn't it like,
just like
yeah,
looking
it's-
for lasers in the sky.
Yeah.
It's like looking for love.
I'm just
One
imagining,
day.
just imagining like aliens having like a rave, like they're having a laser rave,
Yeah.
and that's how we find them. Like, we're gonna find them because they're having a rave.
That's how you find the cool aliens.
Yo, the aliens want to party. Whatever.
Yeah. Well, yeah.
All right. So just quickly before we wrap up, though, there's the large project called SETI, right? The Search for Extraterrestrial Intelligence.
That's right. Yeah.
And they said they reported a few months back, I think it was a few months ago, that there was a signal and that we should look at that some more.
Right. So this actually came out of Russia. So Russia has a giant radio telescope that scans the sky, and as it happened to scan across the star, there was a bit of a blip. And yeah, the media got very excited about it, but the sort of sad reality is it's just all too easy for someone to have switched on their mobile phone at that point, as we discovered about 10 minutes ago. And then you get a blip. And it happens so often that it's actually the main limitation of looking for aliens is we're trying to look for a signal that is really artificial, and we're producing those all the time here on Earth, right? It's hard to escape from when it's so close. So unfortunately, I think that's probably what it was in this particular case, but that shouldn't put us off keeping on looking.
So turn your phones off. I'm looking at you.
And start shining lasers into the sky.
Yeah. Well,
Yeah.
don't, because then they might come and kill us. You know.
I know. Yeah. Well, this is a question that I asked before we started talking. So I'll ask it again. Was like, what are the odds that if aliens find us first, that they're just
Yeah.
gonna just destroy us and just kill us all?
Yeah. Probably pretty high. Yeah. Well, so
Stop scaring me.
the bit of a safety net we have, though, is that we've only been broadcasting radio waves for about 100 years. So they wouldn't have got the signal yet unless they're one of the really, really close stars. It's very unlikely.
Because we would have found them.
We probably would have heard from them by now. So
What if they're really good at hiding?
What if they're made out of dark matter?
yeah. Well, then they can't touch us. We're fine.
Ha!
Can-
Stupid aliens.
Whoa. Like dark matter can't be sentient. No, never mind.
Well, probably not, but I don't want to rule it out.
Terrifying.
Okay, so that's
Oh,
going to
no.
wrap up this portion of the night. I'd like to open it up if anybody has a question for Dr. Fergus Simpson,
Mr. Doctor.
Mr. Doctor. So we got one. Why don't you come up here and you
Yeah,
can borrow
come up here.
Hannah's microphone.
Hi, well, I am Guido, and I want to ask you about your opinion because this is not I don't think there is a close answer about that. I want you talk us about the paradox about Fermi. Why we cannot find extraterrestrial if it's so probable that they can find us? Maybe you can.
Yeah, excellent question. So the question is asking me to elaborate on the Fermi paradox. And the Fermi paradox is simply this. If there are many other places like us where there are sentient beings, then why haven't they arrived here? And what particularly worries people is they've had the galaxy is quite old. So if they'd evolved a few billion years before us, they'd have had time to develop spaceships and come and visit us and so on. And I think there's two main answers I have to that question. The first one is if we happen to be evolving in a galaxy with a super advanced civilization, they wouldn't have let us evolve to this stage. So kind of by selection, we have to have evolved in a slightly more safer environment. We would never have got to this point if there had been some aggressive civilization in the galaxy already. And the second point, which relates back to my research, is that we are not a normal civilization. We should not expect other civilizations to have 7 billion people there. We should expect them to maybe have 10, 20 million tops as a typical population size. And if you imagine a country of that size, like they don't have the capabilities that we do as a nation, as a world of 7 billion. They're not going to have such an advanced space program. And they're not going to have necessarily the resources on their planet to proliferate technology in the way that we do. So I think that's a really big part of the Fermi paradox, is that we're over-egging our belief for what these other civilizations are like.
Isn't that just prejudiced?
Prejudice based on statistics.
I'm not sure that makes it okay.
Well, that's your call.
All right. Any other questions? One in the back. Come on up.
Down.
Hi, so I'm Kadri. I'm reading this very interesting book now. It's called I don't know actually what's it called. So basically, it's focusing on other really unknowable things. You know, like this is something that we really will never truly just because of time or because of we don't have enough gadgets, microscopes or telescopes. So do you think that, for example, in your field there are things that we just cannot know? For example, they were discussing this question, is like what was actually before the Big Bang? I also heard that this is a taboo question, that you're actually not supposed to ask that. And another thing is how can we figure out what's the actual, I don't know what's the right term for that, but this shape of the global universe? Is it any way we can really study it, or do we just have to model it and just come up with ideas and just play around with models? Thanks.
All right, good question. So I'll tackle the shape of the universe first. So it's a bit like if you were stranded on a new planet you've never been to before, and you can just see the horizon, and you're trying to wonder, how big is it? At what point does it curve around? And we're in that sort of position with the universe. We can only see a very short distance, 14 billion years or so, but the universe may well be hundreds or millions of billions of light years across. And we just can't really measure that because light hasn't had the chance to travel across the universe. So unless the universe does indeed curve back on itself very quickly, there's no way of ultimately knowing if what shape it is, because we're restricted to this little viewpoint that we have. And unless we're willing to sit around and wait for another trillion years, it's going to be very hard to measurement to make. So yeah, I certainly think there's a lot of unknowable things. And the multiverse is another example of that. I think there's many indications there are different types of multiverses that could potentially exist. Kind of the most interesting one perhaps is the quantum mechanical one. You may have heard of the many worlds interpretation of quantum mechanics, where pretty much everything that can possibly happen does happen. And it sounds completely wacky, but actually it seems to produce the most elegant mathematical solution to quantum mechanics. So I think it should be taken seriously.
I also like it because it means that there's a world where I am happy and massively successful. Okay, so that's right. So that's our time. But before we leave you tonight, we want to play a little game. Yeah, it's a good game. Don't worry. This is called A Brief History of Science. Hannah?
I'll present it. That's why I was trying to hide the answer.
So we're gonna
Our
ask.
guest.
Yeah, we're gonna ask Dr. Fergus Simpson.
Yeah, so the way that a brief history of science works is I will name a number of inventions or discoveries, and you have to put them in order, chronological order, okay? Right. So here are, it's 3 today. Okay, canned beer, the discovery of Pluto, and shopping carts.
Wow, that's a tough one. Shopping carts, isn't that like? Do they have to have wheels, or how do they?
Yeah, like the the first patented shopping cart.
Okay. Wow.
Leave it to a scientist to be like categorical. Well,
Yeah, I mean,
the ones with the little calculator on the bar, or
yeah, what qualifies? Yeah. So hang on, canned beer was the first one, was it?
Yeah, canned beer, Pluto, shopping carts.
Oh, that's tough. I would have to go. Oh man.
Talk through your thought process
I've
here.
no idea. But I'm thinking they're all going to be in their first sort of few decades of the 20th century, but I'm going to go beer, trolley, Pluto.
don't tell him the answer. Does
Yeah, does someone else have a guess? Does someone else have a
anybody else
guess?
wanna guess? All right, let's do it democratically. Who thinks Pluto came first? Idiots.
No one.
Shopping carts? All right. Still idiots. No, I'm sorry. No, I'm kidding. And
Yeah,
then,
you're doing this terribly.
Yeah, I'm just gonna insult you guys apparently.
Yeah.
And then canned beer. Anybody?
Who thinks canned beer was first?
All right.
Okay,
Anna?
so the actual answer was Pluto was discovered in 1930. The first canned beer came out in 1935. And the invention of the shopping cart happened in 1937. So Pluto beer shopping carts.
Nice.
Yeah, so you were totally wrong.
Yeah.
Yeah.
They were so close. I don't feel too guilty about it.
Yeah, no, it was all in the 30s.
Yeah.
But yeah, so that was a brief history of
Work.
science.
Thanks.
Now you know. You learn a million things every day.
All right, ladies and gentlemen, that is it for us tonight for Comics Curing Cancer. This has been your science talk show. I want to thank Carlos Charms, the best part of the show because he doesn't talk, probably. My co-host, Hannah Becker. This will be available on the podcast network. Christopher Drifter for writing jokes.
Yeah, dude.
And then your very special guest, Dr. Fergus Simpson.
Thank you.
Thank you all.
No, and of course, the host with the most, Matthew Murtha. Give him a round of applause.
You forgot my name. You forgot my name.
Because I was gonna call you the hostess with the mostest. I was like, no,
Stop.
that's not right.
It's true.
I got
So we're going to
flustered.
take a 15-minute break, and then following this program, there's a stand-up comedy show that you're welcome to stay for. It's going to be hilarious, featuring Barcelona's best comedians. Thank
Comedy
you.
Kitchen.
Yeah.
Say the name.
Barcelona Comedy Kitchen.
Woo!
That's right. Thank you for your time. Be sure to like us on Facebook. Join us. Tell all your friends.
All
Right?
your lab mates.
Come back. Next week, we have Francisco, who's a cancer biologist. He'll be telling us about cancer stem cells, yeah?
So maybe we'll actually cure cancer next week.
Next week, I promise.
We
Next
could do
week,
it.
we cure cancer. All right, thank you very much.
Thanks so much, everybody.